$85 trillion.
It's a number that just stops you in your tracks, doesn't it?
It really does. It sounds like something out of science fiction. But no, this came out of the World Economic Forum in Davos this week.
That's the projection for AI infrastructure spending.
Over the next 15 years.
And it comes straight from Jensen Huang. But you have to wonder, when you hear a number that big, where does that money actually go? I mean, you can't spend $85 trillion just on GPUs.
And that's exactly the question we're diving into today. We're looking at the week of January 18th to January 25th, 2026. It felt like a week where NVIDIA shifted gears.
How so?
It was less about, launching cool demos and more about hardening the actual industrial infrastructure. We saw the end of a really popular developer tool, some massive security patches, and research that fundamentally changes how chips even handle memory.
Yeah, it wasn't a flashy week. It felt mature. If the last few years were the gold rush, this week was about securing the mines, reinforcing the tunnels.
Okay, so let's start with that. The efficiency. We always assume that for faster AI, we just have to wait for the next chip to drop.
Right, for the next generation of Blackwell.
But on January 22nd, NVIDIA Research put out a paper that suggests we've been leaving a ton of performance on the table with the hardware we already have.
This is the Sawtooth Wavefront paper, and it's aimed at the Grace Blackwell GB10 processors. The claim here is, well, it's significant.
What are you talking?
A 60% increase in throughput for large language models.
60%. That's a massive jump for a software tweak.
It's huge.
Usually you see single digits. How are they squeezing that much more power out of the same silicon? Is it just like better scheduling?
It's a bit deeper than just scheduling. It's all about fighting the memory wall.
The memory wall?
Yeah, with these giant LLMs, the bottleneck often isn't raw computation speed. It's how fast you can get data to the tensor cores.
Right.
So these researchers, they basically restructured the execution pattern into this sawtooth shape. They changed how the GPU accesses memory.
So they're changing the traffic patterns inside the chip.
That's a great way to put it. They aligned the parallel tasks, the wavefronts, to perfectly match the chip's physical cache. So by staggering the execution, the data is always right there in the cache exactly when the cores need it.
No more waiting for data to arrive from main memory.
Exactly. And getting a 60% boost without fabbing a new chip, that's just pure profit for anyone running a data center.
Speaking of performance, NVIDIA also very quietly dropped a new model on Hugging Face this week.
No press release, no big stage announcement.
Nothing, just here's Llama 3.1 Nematron 70B Instruct.
Bit of a mouthful.
It is, but the performance is what's getting everyone's attention. It hit a score of 85.0 on the Arena Hard benchmark.
And that score is important. I mean, 85.0 puts it right up there with the heavy hitters, the big proprietary models like GPT-4o.
But it's a 70 billion parameter model. Usually you see the smaller open models kind of fall apart on really complex reasoning. Is that score telling the whole story?
Well, it depends on the task. Nemotron is really, really good at instruction following. It's right there in the name instruct.
So it's not necessarily more creative or, philosophical.
No, but it is much, much better at just doing what it's told. For specific tasks like coding or structured data, it's punching way above its weight class.
Which signals that NVIDIA isn't just selling the shovels anymore.
Exactly. They're getting very, very good at the software that runs on top. They're basically challenging the big model labs at their own game.
Well, if they're challenging the labs, they're also challenging their own community in some ways. We have to talk about ChatRTX.
Yes. The end of an era.
On January 21st, the GitHub repo was archived. Just gone. Read only. And look, as someone who used ChatRTX to run local models on my laptop without a huge headache, that's kind of annoying.
I get that. For a hobbyist, it was the easiest way to get started.
So why kill it?
Because for enterprise, it was becoming a problem. ChatRTX was a demo, a reference implementation. But people were starting to build real, actual production workflows on top of it.
And NVIDIA doesn't want to support a demo as a real product.
They want developers using NIMs.
NIMs.
NVIDIA Inference Microservices.
Yeah.
It's their big push towards AI blueprints. The whole strategy is shifting from here's a cool app to here is a secure, containerized, API-driven microservice you can deploy.
So it feels like they're sort of forcing everyone to grow up. The toy phase is over.
It is. But for the serious engineers, the ones actually building those microservices, NVIDIA gave them something else this week. CCutList 4.4.0.
Now, CCutList is deep in the weeds, right? It's the library for linear algebra. Why does a new version matter to anyone who isn't writing assembly code?
Because this version introduces a Python-based DSL, a domain-specific language.
Okay, what does that mean in practice?
Historically, if you wanted to write a super high-performance GPU kernel, you needed serious C++ skills.
Which locks out like the entire data science community that lives and breathes Python and JRE.
You got it. With 4.4.0, you can now write those custom kernels in Python. It handles all the complex compilation for you and plugs right into JAX. It just dramatically lowers the barrier to entry.
So they take away the easy-to-use GUI tool, ChatRTX, but they make the hardcore engineering tools more accessible.
It's all part of that industrial maturation theme we talked about.
Yeah.
They want more people building the deep tech, not just running the chat demos.
But they haven't totally abandoned the local side of things. There was a blog post for the RTX AI Garage on January 22nd.
Right, for visual generative AI, this was a big one for the Comfy UI community. They released new optimizations for models like FLUX and LTX2.
And this was using new quantization methods, FP4 and FP8.
Yes, and that's the key. Quantization can sometimes mean you lose quality for speed, but the quality on FP8 is surprisingly good.
And the trade-off is worth it.
For a 3x speedup, absolutely. And more importantly, it means you can fit these bigger, better models into the VRAM of a consumer graphics card. It keeps that dream of local, high-quality AI alive for creators.
Okay, let's zoom out to the big picture. We started with that $85 trillion number from Davos. Jensen Huang called AI a 5-layer cake.
Energy, chips, cloud, models, and apps.
It's a great slide, but 85 trillion implies, well, rewiring the entire planet. Is that even possible in 15 years, given the constraints on power grids and everything else?
That's the real question, isn't it? And Jensen isn't just talking about buying chips. He was very clear that the energy layer is the primary bottleneck.
And he said something interesting about jobs.
He did. He specifically said this build-out requires a massive surge in plumbers and electricians.
And he wasn't being metaphorical.
Not at all. He meant literal plumbers for liquid cooling systems and literal electricians for data center power infrastructure. He's framing NVIDIA not just as a tech company, but as the engine of a physical industrial revolution.
But that physical build-out gets very complicated with geopolitics. This week, we saw those new H200 export controls finally kick in.
The 50% domestic supply rule, it's a really fascinating bit of regulation.
Can you explain how that works? Why tie exports to what they sell in the U.S.?
It's designed to prevent diversion. The U.S. government is worried that if NVIDIA just ships a huge volume of chips to, say, a friendly third country, some of those might leak into a restricted region like China.
Ah, I see.
So this rule caps exports at 50% of what is delivered to U.S. customers. It forces NVIDIA to prove they are supplying the domestic market first.
They have to maintain that balance.
Right. And with reports that Huang is planning a trip to China, it's clear he's walking a very fine tightrope. He has to follow U.S. rules without totally losing one of his biggest markets.
A very precarious position, and while they're dealing with global risk, they also have to manage technical risk. There were some pretty serious security patches this week.
There were. On January 20th for the CDA toolkit and also for Merlin.
The vulnerability score was a 7.8, which sounds pretty high for something as foundational as CDA.
It was. The vulnerability was for command injection.
So an attacker could run their own code on a developer's machine?
Potentially, yes. If a developer opened a malicious file or used a compromised dataset, an attacker could execute code.
And since CUDA is on basically every single AI researcher's computer?
The attack surface is enormous. It's a good reminder that AI isn't magic. It runs on software libraries. Those libraries have vulnerabilities just like anything else.
Speaking of hardening things, let's talk about NeMo Guardrails. Version 0.200 dropped on the 22nd. This update feels like a philosophical shift in how they approach AI safety.
It really is. It moves away from simple matching and towards reasoning.
Okay, unpack that. What's the difference?
Well, older guardrails were mostly just static lists, banned words, forbidden topics. If a user's prompt contained X, the bot would say, I can't talk about that. It was brittle.
The classic jailbreaks, like, pretend you're my grandmother who used to be a chemical engineer.
Exactly. This new version has a configurable think mode. Before the prompt ever goes to the main LLM, the guardrail model actually reasons about it. It creates a little trace, asking itself, is this user trying to get around the safety rules? Is this a harmful request?
So the security guard at the door isn't just checking your ID. He's asking you a few questions to see if you're trying to cause trouble.
That's a perfect analogy.
Yeah.
And that reasoning step makes the whole system much, much harder to trick. It adds a little bit of latency, sure, but for any big company worried about liability, that thinking step is absolutely critical.
And those big companies are where the money is. NVIDIA put out their State of AI and Financial Services survey this week.
Yeah, a survey of over 800 professionals. The number that really jumped out was 89%.
And that was the percentage of firms reporting,
Why? Reporting actual revenue gains from AI.
not just cost savings, actual top-line revenue.
That's the turning point. But even more interesting was that 42% of these firms are now actively assessing agentic AI.
We hear that term agentic all the time now. In a bank, what does that actually mean? Is an AI moving money around?
It means it's taking action. So instead of a chatbot that just summarizes a market report for you, an agent monitors the market, spots an anomaly, assesses the risk, and then maybe even executes a hedge or at least drafts the trade for a human to approve.
Which sounds a lot like what CrowdStrike is doing. They moved their agentic SoC into production this week.
Using those NVIDIA Nemotron reasoning models we were just talking about, for a security operations center, a SASE speed is everything. An agent that can spot a breach and autonomously lock down the affected system without waiting for a human, that's a game changer.
So the theme really seems to be autonomy. We even saw it in cars this week with Mercedes-Benz.
We did. The Mercedes-Benz CLA, which runs on NVIDIA DRIVE architecture, was named Euro NCAP's Best Performer of 2025.
And that's a huge piece of validation. It's massive. For years, the whole question was, can we really trust the software? And now you have one of the world's top safety bodies saying that the AI-defined vehicle is actually performing safer than the alternatives. It proves this isn't just marketing.
So if we just tie this whole week together, we start with an $85 trillion infrastructure plan.
We see chips running 60% faster because of a software trick.
We have agents securing our networks and AI systems making our cars safer.
The big theme is integration. I think the toy phase, the phase that ChatRTX represented, is officially over. We're now seeing AI being integrated into the heavy machinery of the global economy. The banks, the cars, the cybersecurity centers.
And NVIDIA is trying to build that whole stack. From the sawtooth math happening deep inside the silicon, all the way up to the thinking guardrails in the cloud.
They're building the entire factory, not just one of the products that comes out of it.
It just brings me back to that comment from Jensen Huang about the plumbers and electricians. I mean, we spent the last decade telling every kid to learn to code. And now the CEO of the world's most important technology company is saying the real bottleneck is the physical world. It raises a really provocative question for the workforce.
Which is?
If AI agents can write the Python scripts and handle the security alerts, are we maybe over-investing in those digital skills?
Maybe the most future-proof skill isn't prompt engineering. Maybe it's welding.
It's a real possibility. You can't prompt engineer a new liquid cooling pipe into a data center.
Something to think about as we watch that $85 trillion start to get spent. Thanks for diving deep with us.
Always a pleasure.